Alright, so in this problem, I have 0.2 to the power of x is equal to 2. So for this problem, I want to find the value of x. So for my solution, first start with 0.2 to the power of x is equal to 2. Now I'm going to take the log on both sides. So I have log 0.2 to the power of x is equal to log 2. And if I have something in the form log a to the power of b, I can actually move this exponent b here to the front. So this can equal b times log a. So in this case, I have log 0.2 to the power of x, and I can move x to the front. So now I have x times log 0.2 is equal to log 2. Now if I divide both sides by log 0.2, these two cancel out, and I get x is equal to log 2 over log 0.2. Now, if you notice here, log 0.2, well, that's the same thing as log of 2 over 10. And if I have something in the form log a over b, this is simply equal to log a minus log b. So in this case, a is 2 and b is 10. So I can rewrite this as x is equal to log 2 over log 2 minus log 10. Now, log 10, as we all know, is simply 1. So I have x is equal to log 2 over log 2 minus 1. Now, log 2, this is equal to 0.3010. So I have 0.3010 over 0.3010 minus 1. And now this is equal to 0.3010 over 0.6990. And finally, if I divide these two, I get that x is equal to, this is actually negative 0.6990. X is equal to negative 0.43. Alright, so in this problem, I have 2 to the power of x minus 2 to the power of y is equal to 120. So just looking at this problem, we can see that x is going to be greater than y. And this is because if x were less than y, then this would result in this here equaling a negative number. But because x is greater than y, this is why it's going to equal a positive number. Meaning, if x is greater than y, then x is going to equal y plus some number k. So k is a constant. So now, if I go ahead and replace x with y plus k, I get 2 to the power of y plus k minus 2 to the power of y is equal to 120. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of y plus k, and we write that as 2 to the power of y times 2 to the power of k. Now I have this minus 2 to the power of y is equal to 120. Now if I factor out 2 to the power of y, I get 2 to the power of y times 2 to the power of k minus 1 is equal to 120. So now this gives me two equations. I have 2 to the power of, before that actually, 120, I can go ahead and rewrite as 8 times 15. So now, as you see, This is going to give me two equations. We can think of 2 to the power of y as 8 and 2 to the power of k minus 1 as 15. Because 2 to the power of y, this is going to be an even number, right? 2 to the power of any number is an even number. And 2 to the power of k minus 1, well, 2 to the power of k, that's an even number, and an even number minus 1, that's going to be an odd number. So notice how this is in the form a number times a number is equal to number times a number, meaning this number is going to equal this number, and this number is equal to this number. So now I have 2 to the power of y is equal to 8, and 2 to the power of k minus 1 is equal to 15. So for 2 to the power of y equals 8, y is going to equal 3, because 2 to the power of 3 is 8. So that's our solution for y. And for 2 to the power of k minus 1, add 1 on both sides. I get 2 to the power of k is equal to 16, meaning k is 4. So now that we have our value for y and k, remember x is equal to k plus y, meaning x equals 4 plus 3, which is 7. So these are my solutions. Alright, so in this problem, I have x to the power of 4 is equal to x minus 1 to the power of 4. So to solve this, I'm going to first start by subtracting x minus 1 to the power of 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus x minus 1 to the power of 4 is equal to 0. Now, x to the power of 4, that's the same thing as x squared to the power of 2. And x minus 1 to the power of 4, that's the same thing as x minus 1 squared to the power of 2. So now this is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared, and b is x minus 1 squared. So now I have x squared plus x minus 1 squared times x squared minus x minus 1 squared. This is equal to 0. Now, x minus 1 squared, let's go ahead and expand that. That's going to equal x squared minus 2x plus 1. So I have x squared plus x squared minus 2x plus 1 times x squared minus x squared plus 2x minus 1. Because remember, you got to distribute the negative sign. And this is equal to 0. So now, let's go ahead and simplify this. X squared plus x squared is 2x squared. So I have 2x squared minus 2x plus 1 times x squared cancel out. So just 2x minus 1 is equal to 0. So now this gives me two equations. I have 2x minus 1 is equal to 0. And I have 2x squared minus 2x plus 1 is equal to 0. So for 2x minus 1 equals 0, x is simply equal to 1/2. That's a simple equation. And now for 2x squared minus 2x plus 1, we're going to use the quadratic formula, which is negative b. So negative of negative 2 plus or minus the square root of b squared negative 2 squared, which is 4, minus 4 times a, which is 2, times c, which is 1. And all of this over 2a, so 2 times 2, which is 4. And now this is the same thing as positive 2 plus or minus the square root of 4 minus 8 is negative 4 over 4. And as you can see, we have the square of a negative number, which we can't do. So my only solution here is x equals 1/2. So x equals 1/2 is my answer. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now, if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now, x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to, this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, And the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these 2 places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20.